Hello everyone, I want to welcome you to another tutorial example. This is going to be for very basic tutorial 7, and I'm going to, as always, go over some of the previous examples, which is only one example we have for the dim example, or dim multi-dimension array examples, and then kind of move forward. So let's get started. So last time we covered multi-dimension array examples. I've actually modified this to make it a little bit easier to understand. The rows, actually, I've misrepresented this last time. The rows are actually going across like this. So R0, R1, R2, R3, and R4. And then the columns are going down. So if you want to look at the example last time, okay, so here's an example of the last program we used, where we used R equals 1 to 10, or C equals 1 to 5, even though I don't have this data set up this way. Just wanted to show you that the R equals 1 to 10 is everything going across like this at the top here. So all of these are the R1s. R equals 0. In this case, it would be 0 to 4. This is just row 1, row 2, row 3, row 4, row 5. If you want to consider it this way, this will be row 0. According to our example, this is row 1. This is row 2, 3, and 4, and so on. This one would go all the way up to 10, but obviously we can't get them all in here unless I made this larger. But I wanted to show you that. So that's what that row equals, and actually I had this as 1 equals 10, so let me just put that back the way it was. Okay, so 1, 2, 3, 4, 5, and so on. So this would actually just be over the 4, so if we left it like that, that would be good. 0, 2, I'm sorry, so we got 0, 1, 2, 3, and this example goes up to 10, and then you got C equals 1 to 5, and 0, 1, 2, 3, and maybe 4, 5, and this would just be where all the data would be filled. I'm showing you this because this is actually the for example. Let's put down a for example so you can see the R is for the R. Stop changing my R. And then the other one, the for example, would be for the C, of course. Keeps wanting to change my stuff. So hopefully that makes sense to you. And then the columns are just going down 0, 1, 2, 3, and so on. In this case, it's got to rename this again. I had made another example earlier and I modified it, but it never got saved, so I had to start over here. Sorry about that. So this would be 1, 2, 3, 4, 5, 6, all the way up to 10. And like I said, this is the row 4 going across, and then this is it going down. Now you see this x equals 0. I wrote this up so people could understand it better. So 0, 0. If we run this program, for example, oh, we got to stop it. I forgot. It's a for loop. And just clear the screen. Whoops. Trying to get this all on the same screen here. I'm going to move this over. I'm not going to have enough room. We'll just clear the screen here real quick. And then if we print x 0, 0, we're going to get the first row there. And if we print x, remember, we're going to keep that 0 the same. And why didn't it save? Let's see. I saved it in the x. I don't know why x. Oh, it's 1. That's right. My bad. Sorry about that. So it actually starts at 1, since in this example we're starting at 1. So x 1, 0 would be the first row, and then x 1, 1 would be the next. You see the data showing up now. X 1, 2. And let's see what lines those data is stored in. So it's 170. So I'll run this again and show you what I mean. And if we list 170, you can see it's printing the values 0, 1, 3. So it's basically printing these in order. And notice I'm only changing the second value on the first round. Now if we go through the second round, and we just start, for example, and change this to 0, or I'm sorry, not 0, it would be 2, and then change all of these just to 2s, you'll see the new data appear as I go through each one. You see the 0, 2, 4, and we change this to 180, so we can look at that line. Hopefully that's it. And you can see Not sure where the 2 came from there. Oh, because I probably just started at 0 again. That's why. These aren't starting at 0. These are starting at 1. Getting this all messed up. Sorry, guys. It starts at 1 because I'm just using 1. So there we go. 2, 4, and 6, and so on. And if we go to the next one, we could change this to 3. And just put those in. 5, 10, 15. And I look at 190. It should be that. 5, 10, 15. So hopefully that makes sense. That's just going across. And as we're changing this number, we're going down the screen. So that's just the row and the column. So that's all I wanted to spend on that. Let's move on to the next program so we don't waste so much time here. We're going to learn about GOSUB now. Just right down here below all this. And I'm just going to go ahead and type this little program in there. I'm going to pause so I can save time here. Okay, so I've got my program entered, and this is going to teach you about the GOSUB routine. Now, think of GOSUB very similar to GoTo. Now, when we use GoTo, we're going to a line, and we're never coming back to that line. We're just going, so we would kind of repeat in a loop. We've seen examples if you just like print a name or whatever and go to line 20, go to 10. It'll keep repeating that loop and keep repeating that text down the screen. So we'll go ahead and run this one, and then I'll demonstrate this and explain it. So you basically, it's telling you to enter a number. So if I enter 10, it's showing subroutine 100. So basically, this is showing the line that it went to. It went, if you look up here in the program, you can see it says GOSUB 100, and I'll explain that here in just a number. Let's just stop our program for now. And let's get back to the screen. So what we got going on here, the first thing we're familiar with, this is our string, and this is basically setting the character of subroutine inside of a string, so we can, print the word subroutine inside of a value here later. And then this one is going to take the string of B strings and then set the value of program in it. And then we're going to have a little loop. We already know what those do. They basically do incrementing and repeating of stuff. So this goes from 1 to 5, so it's going to count from 1, 2, 3, 4, 5. And each time before we're finishing our loop, we're going to use an input and ask for a number each time. So upon each iteration, it's going to say enter a number as it goes through the loop each time. Now, I probably didn't demonstrate that, but I could. So if I did 10 the first time and I did 20, you can see how it's changing. Basically, what it's doing is it's switching out the subroutine. I noticed that. So it's basically increasing it there. And actually, what it's, no, I'm sorry, it's not doing it. It's just creating a power of a number down here, which I'll come to that in just a second here. So going back over this again. So we got our first values. We're repeating the loop. We're doing our input statement to get our value of x. That's just a numerical value. And then we're GOSUBing the 100. So excuse this 100, 200 you saw on the screen. That's not changing the GOSUB. The GOSUB number is always going to be the same, and I'll explain where those numbers came from in a minute if you haven't caught that. So basically what it's doing is it's saying as soon as you enter a number, go to line 100. Okay, in line 100, we're saying print a string. We know earlier we had defined a string as subroutine. So print a string, if I just do it on the screen here, you'll see, oh, I don't know why that just happened. I just had some weird data pull up on my screen there. That was really strange. But anyways, if I go here, let me just run it again and enter the value. Okay, so I'll stop it here and show it to you, and we'll just clear it. Commodore keyboard, gotta love it. It emulates to a Commodore keyboard, so the keys get moved around. So now what we're going to do is we're going to print, as I said, our A string to show you what that's doing. So see, as we went to 100 here, inside of the loop, after we entered our number 100, it went to A string and it printed the word subroutine, just like we saw in the example, and then it prints down a line. And then this line here is creating a power of a number, so I'll demonstrate that down here with a different value. But if I print Z here, you'll see that, actually you won't because it ended the program probably because I broke out of it. But I'll show you anyways as I do it right here. So let's say Z equals, hopefully X is still in memory. Let's see. Commodore 64 is a funny way of wiping out data all the time. So I'm going to just hopefully it doesn't kill it this time. I'm going to have to make it end or something because every time I break out it loses the value. There it goes. Okay, now we got the value left in memory finally. So if we print Z, we'll see it's showing 10,000. And that's basically taking the number that you entered, which was 100, and putting it to the power of 2. So it's the same as doing, 100 to the power of 2. So you say 100 to the power, you hit the delete key on your keyboard to get to it, and you hit 2, and you get the same result. So that's basically all it's doing. It's just showing you how to print to the power of a 2. And this return, keep in mind this return, once it hits a return, GOSUB means go to subroutine. And once it finishes the subroutine, it finishes everything up to return. Once it sees a return, it will go all the way back to the next line underneath it. So basically, it's a way of it starting to the next routine. GOSUB is used if you need to repeat a lot of data. I've used it in like whenever you're delaying routines, whenever you go to create like a setup, for example, like initialization. We'll see that in later programs as we go along. So as you basically start setting up subroutines like your graphics display, your sprites, you're going to GOSUB to 1000, GOSUB to the 2000, wherever that data is stored. And as soon as it hits a return, it goes back to that last line underneath the GOSUB to get the next statement. And actually, if you have a colon after here, I should mention that it'll actually continue right after here. So whatever's after that GOSUB, it's going to hit that next. If there's not a colon, this goes to the next line. So it's pretty self-explanatory, so I hope that makes sense. I'm going to move on to the next stuff here so we can keep trying to move forward here. Because there's some other good stuff I need to show you. So I'm going to go ahead and I'm going to save this, and I'm going to come right back here with the new program, and I'll have it entered in. Okay, so I've got the next program entered in, and what we're going to learn now, we learned about GOSUB earlier. Now we're going to learn about something called on GOSUB. And I've left this on the screen here so you can kind of see this Word document. And what I'm thinking about doing is throwing this Word document in my GitHub too, so you can kind of follow along with it. It's not complete because I started most of it on the paper, but I'll try to put it all in here later. But I'll throw it up there so you guys can kind of go through the examples and kind of read it for yourself and learn that way. So that's one of the things I'm trying to do now anyway. So anyways, what we're doing here as we're going through each line here, we're going to first enter a number between 1 and 5 for line 10 here. And this is basically, we'll just go ahead and run the program like usual. So it's very similar to the first one. So now we're going to be, except we're going to be entering a number. If I enter 4, it'll tell you what my number was and it'll end. So it'll always tell you what number you're entering. Now if you try to enter a higher number, it won't do anything because it's not programmed to do that yet. So 1, and I'll show you. We'll go back and list it here again, and I'll explain it. So we know print is just going to say enter a number between 1 and 10, 1 and 5 on the screen. And we know our input X is stepping in a numeric value that you can enter after the question mark. And then you notice where it says on X, GOSUB 100, 200, 300, 400, 500. And to demonstrate this, I'm going to set this as stop so we don't lose our numbers. So now it's stopped, and our number will stay in memory there. So I'll show you reason why I did this. So if we print X, we'll see that we entered 2, right? So it says on X. So what this is doing, it's saying, which one of these am I going to go to based on whatever X value is? So whatever value you put in for X, it's going to go to that line. So this is great. It's called branching. And it's used a lot in examples like if you want to register the joystick, or if you have a graphics routine, there's a lot of great things you can use for it. And hopefully we'll come across more examples later as we learn about it. So what it's essentially saying is if this value is 2, I'm not going to line 100. I'm going to go to line 200 since that's what you have set up in this routine for the on X. And it's going to print right down at this line, of course. So if I'm going to 3, for example, 300, then I'm going to go down to line 300, 400, 500, and so on. Now I'll set up a new line just to show you. We'll set up a totally different value outside of the 1 to 5. We'll set this to 100 and make it say your number was 100 and then return. Now you also have to add it to the data or it won't know. It'll just might give an error message or it just might not do anything. So now if I enter 100, it'll print. Oh, why did it break? Let's see, X. Oh, I know why. I'm sorry. I tried to make it do something I wasn't ready to do. So if I go down here and I print X, which is 100, 100 would not exist in X. You can't make it go from 1, 2, 3, 4, 5, and jump to 100. The system's not set up to do that. It'll automatically, now if I enter 6, it should work. But it'll say 6, it'll say 100, of course. See, that's what it is. It goes in sequential order. I was thinking I could jump it out of order, but that was my mistake. You can't force it out of order unless, of course, you have something in this X starting at 100. So with input X, it's always going to go there, or whatever you have in for X here, it's going to follow that data to figure out which line to jump to. So hopefully that doesn't confuse you too much. Think of it as just jumping around using GOSUB, because remember, every time it hits a GOSUB, if it hits this one, for example, if you typed in 2, it hits return, it's going to go right back to this command right after the GOSUB. Now, I know I said earlier the colon and all that, but it's still going to follow the command of the X, which is right after the comma, essentially. So it'll just look for the next one, the next one, the next one, and so on. But it's not going to execute them all in order since it only receives one value every time. You can't make it say GOSUB the 200, then GOSUB the 500. It won't understand what you mean. You'd have to set up a separate on X for that, as far as I know of. If I tried it here, for example, let's say if I tried, let's just say I tried 2 different numbers or something. It won't do anything. It'll just skip the data and it'll stop the program. It doesn't understand what you're trying to do. So essentially, it's looking at 12. It's interesting, it concatenated and my numbers together there. And there's obviously not going to be any 12 unless you were able to start this at 12. And then from the loop, it could actually increment and go to that line. So even if I entered something like 12, it still won't know what's going on because the X is always going to start at 1. I don't think it starts at 0 either. Let me see. Yeah, it doesn't even actually start at 0. It's always going to start at 1 every time. So hopefully that makes sense to you. You can use those in other program examples. I'm going to move on to the next example here, and I'm going to save this. Okay, so we're finally going to move on to accessing RAM, ROM, and knowing how to access and use peek and poke statements. I've been waiting so long to do this because a lot of the times I haven't been able to do stuff with the screen. I've been wanting to change the color of the screen, and I haven't been able to do it since there's no other commands to do it. So we're staying in order of the book. So keep in mind, as you look at an example here, that RAM is random access memory, and ROM is read-only memory, and I'll enlarge this if you need to see it. For those who may be visually impaired. I dated a girl who's visually impaired before, so I can relate. Okay, so move down here a little bit. So your computer's memory contains RAM and ROM. So RAM is random access memory. RAM is like your basic program. When you type new, it goes away. It doesn't come back. There are ways of bringing it back, but mostly just to say when you type new, it's gone. I did type new earlier, so if I list it, it's not there anymore. And ROM is actually stored in your memory. So this is actually all of the information in your computer from the I/O, like the disk operations, to this everything hidden in that's stored inside behind your screens, going behind scenes, like everything that runs in through, like for example, when we use this load string command, which I'll show you here. You'll see that what this does, it's kind of like the catalog for the computer, and it just shows you what's on the disk drive. So what it's essentially doing is it's using the ROM memory to locate this load, and then the colon, the quote, as we saw earlier, the quote string like that, and it's saying if there's a $sign after this load, then I'm going to access the directory. There's a lot of other commands you'll learn about as we start playing around poke, and I want to go into those, but I also want to mention this. ROM houses over 64,000 memory locations within the unit, and each portion of memory carries out specific tasks. These are actually the functions. This goes more into machine language, so we probably won't go there right now. It also stores all of your variables and tokenizes them and everything so that you can access them. It keeps track of every variable in your Commodore 64 program. It keeps track of your program in general. So what I meant by if you type new, there's ways of getting it back. It's not totally rewritten over unless you start writing a new program, of course. Essentially here, I wrote as you learn more about the machine, you'll discover the computer, control the clock. This is what I was talking about, sound registers, graphics I/O, many other functions hidden deep below the surface. And then we're going to go over this in just a minute. Now I'm going to pull up a book here real quick and show you. You've seen this book before, Map of the Commodore 64. One of my favorite books for the Commodore 64. It's a reference guide. And this houses all of the memory locations in your computer. You see there's one right there, for example. That's a maskable interrupt, just as an example. And we'll learn how to access those individually. So this is where we're going to eventually get into sprites and all this. Probably not in this example because we're already at 20 minutes, but we're going to get pretty close now. So let me go ahead and just pull this data back up here so we can stay consistent here. So the next thing here is I wrote here, we're going to discuss this, the peek statement. And the statements used to access the functions, and I call them the memory pockets. The first one, it basically peeks inside of memory. It looks for a value found in a memory location. And if you remember earlier, the boxes, I said the boxes, but up here we had basically the table, like this, the table. So if you recall the table here, and I go back down here to this line real quick. So the values are basically stored in memory locations, just like those array, those multi-dimensions were stored. There's values stored inside of your computer's memory that's keeping track of data running behind the scenes. And basically, so a lot of this data is set to defaults and stuff like that. So, like I said, if you imagine, think of the boxes lined up, just as we saw that table, from 0 to 655.35. So if you imagine that, that's, this is basically starting at 0, this would be 0, and this would go all the way over to 65,535. I may have that number off, but that's basically what it does. It keeps track of all of these memory locations. So, for example, if I even poke something, the book here kind of goes up, doesn't really show me what the very last routine's doing. I might end up locking it up if I try something deeper. But let me take a look here real quick, and we'll see what it goes up to, and I'll just show you. It actually goes up, this one's showing 65,534. I'll just show you that real quick there. You see it at the bottom there? 65534, it's a maskable interrupt. So if I use that one, it'll probably lock up the computer. But what you would basically do, if you could access, you would poke 65534, and you would set a value after it. I'm not going to do it because I don't want to lock up anything. More afraid it might. I mean, I could do it if it locks up. I could always just restart it. It doesn't really matter. Okay, everything wants to load now. So if I just type this value, it might not do anything. So apparently it didn't. But what you may not know, and this is stored in memory here. Gosh, let me type it. Okay, so if we go and peek in that location now that we just entered, we should see a 1 in there. Oh, actually, you know why we don't see a 1? I can tell you why. Because this memory itself is set for ROM only, so we can't write over this data. This is already kind of locked. If I try to go in here and I try to type in a value, and then I try to peek and see if there's a 2 in there, it's going to leave 72 in because these are already off limits, basically. This is where our ROM data is stored. Now, if you wanted to use these values, you have to kind of move them into another memory location, but that's a more advanced example. I just wanted to show you that what you can do on the second value is you can poke up the 255. So the value can go from 0 to 255. So I put a 0 in there, whatever. I put 255, I'm good. Now, if I try to put a number higher than 255, I'll get an error message, since you can't put more than 255 values in a poke statement. And it has to do with the way the memory's set up and all that. But don't try to put in more values than are necessary. So we're finally going to get into some good examples. I'm going to show you one I've been waiting to show you for a long time. Very simple, but it's going to change the color of your screen. It's 53, actually we'll do the border first. 53,280, and earlier we saw that 2, so we'll use our 2 again. Now watch, as soon as I entered 2, you saw the border change color. So basically this memory location is housing where the screen data is storing to change the border color itself. So any number we put after here will work. If we put 5, you'll see the screen change to whatever value I'm changing it to afterward. Now if you go to 16, it goes to 0 and it will kind of restart again. So it's only going to do 16 colors at a time. So 1 is essentially the same as 17 and so on. But you can check them all out just by typing them in and taking a look and seeing what they do. So it's kind of pretty up your screen there a little bit. So the next one we're going to learn is how to change the background color. And I'll just start by, oh, and before I do that, let me just print into this location to show you that this is actually accessing where you can actually see what you just entered in here. So, oh, it actually doesn't show the right value. Did I do this right? I put print peak 9, excuse me, 53,280. Messing myself up here. So I put a 9 in there. So whatever value I put in there, it's going to remember it now, since it's able to recall it, and it's not off limits, so to speak. So we're going to the next one, 53,281 was 0, and now this is going to change the background color of our screen. You see our screen is now black. Of course, if we peek in there, we're going to see a 0. And if we type 2, that 2, it changes it to a red, and if we hit this, we'll see the number 2 is in here now. So whatever data you're storing in here, it's just going to keep changing it based on that. And you can see how you can always peek the values to get them back. So hopefully that makes sense. And like I said, this book, you'll want to get it. Map of the Commodore 64 has all of the memory locations, and we'll go over it. You probably see me doing this in a lot of my examples where I've used sprites, sound, and all that, because it's all stored in this book. So it's a great, great resource to get. I will mention that 100,000 times. It's a great resource to get times 100,000. So anyways, let's see what else we have in here. I'm just going to pull this back over so I can stay consistent and don't get carried away. So I showed you every time you hit the enter key, it's going to show you the value after that. And I just kind of explained how it's related to the variables and references of value. This one they're using the 650. This changes the speed of your computer. We could do it right here if you wanted to see it. Or 650, was it 96? 650, 96. And what it does is, now if you hold the space bar down before, it would always move the cursor automatically. Now I'm holding the space bar, and I have to keep pressing it for it to it's not going to repeat. Now if you set it back to 0, and if you also peek into this, you'll see that memory location. So I'm just using the question mark for shortcuts. 96. And if we plug it back to 0, then now we can move the cursor automatically. Okay, so I already explained how they get reset every time you type them in. And let's see here. Okay, so I'm going to read this. So earlier when we were talking about ROM, keep in mind ROM does not allow a value to be poked in that memory location. I think I did mention that. You can try to poke it in, but it's not going to recover it. Since it's already hardwired into the chip, in order to poke into ROM, you have to move memory. I did explain that. An example of this is move your computer's character set, all the characters you can see on the screen here, these are your character set, into RAM so that you can change data to your own character set. This is getting a little bit more advanced, so basically what this is doing is just finding an area in your computer's memory. So basically it's finding an area safe in one of these memory locations stored in here, and it's able to move them. For example, I know one by heart. It's 49152 right there. This is actually used by a lot of machine language programs. You can move data into that area too if you wanted to access some of that, ROM memory. A character set, since it's stored in ROM, you have to move it to RAM to change it. Okay, let's see what else we got here. Okay, so this is moving on to our next example here. I just wanted to make sure we covered everything here. I think we're good there. So I just also mentioned here that to redefine a character set, you could change like characters to a spaceship or whatever you want it to look like. We'll get into that much later. Since it doesn't cover in this book, I don't want to go out of range. So let's move on to some other examples here, and let me save this program. Oh, actually, there's no program to save. Never mind. So we'll just go on to the next example. Let me just shrink this back down. So the next thing we're going to be covering is, we learned about this one earlier, but it's the ASC. Basically, it gets the PETAXC value on the Commodore 64. So if you see a Q in there, I'll put the Q as an example. And you'll see at 81. Now, what does this mean? Let me pause for a second. Okay, I'm back. If you look at the ASC value here of 81, as I'm holding up the book as best as I can, you see it shows 81. And if you look right beside it, you see the letter is Q. So whatever these letters corresponding is, it's going to show you what's ever at this ASC. And this is basically how you access the character set in your memory. This is just in the back of the book. This is the same reference guide that we're using for these examples. It's the C64 user's manual, or any owner's manual you get. And you just go back into the book, and I think it's in the appendix. This section, it's actually in Appendix D, right there. So Appendix D, and you see it says screen display codes, and you see those at the beginnings, and it just kind of goes through them and shows you them in order. So these are very, very valuable. You always want to make sure you use these a lot, because I don't have them all memorized. You always want to know where those data are stored. You want to go to your appendix, and you can pull them out. So any value we type in here, so if we do, it's going to basically keep any track of anything that's on your keyboard. From 0 to 255, it stores all the characters. It's going to show 65, since that's the... Now, if you also do this, CHR string 65, I think I might show this earlier, you'll see it does the reverse, and it prints this back this number, and it prints it back into a character. So this is how we get it on the screen. When you saw me doing 147 and all that, it's just basically accessing the clear screen. I'll do it right here to show you, and then I'll just print it on the screen here to show you an example. And let me just look it up real quick here. Hopefully it shows in here. It's right here. It's going to kind of move it in and zoom it in down here. Look for 147 here, and I'm using my mouse to show you. Hopefully my camera picks it up right here. You see it says clear home. Now this one's probably not a good example, but what this is doing is if you do the clear home on your Commodore keyboard, it prints that little heart, and your heart clears the screen, so it's all doing the same thing there. It's just a way of clearing the screen, clearing what's in your computer's memory. So if I enter any other value after this, it's going to always look at that value. For example, if you do 142, this will switch to lowercase. I'm supposed to. No, I guess it didn't. Make sure this is the right character set I'm looking at. Could it be actually looking at the wrong one? This is a screen display code. Looks like it is the right one. Yeah. But anyway, it's always going to show you what's after that character. So if you want to see the whole character set, let's just print it to the screen here. I'm just going to print up to 146, otherwise it'll clear the screen for now. But you can do it up. We can do it at 255 just to show you first, and then after it clears the screen, then we'll have it rerun again, and we'll make it print in order on the screen so we can see all the characters. Now it's going to clear the screen once it gets. It's going to probably go real quick, and once it hits 147, it'll clear the screen so you won't see everything. It clears and goes on to the next character set. So if you want to see them in order, and we'll go back to our poker example. I wanted to show you if you use 646 and the value after it, it changes the color of the text. Earlier we saw the background. I wanted to show you how you can change the color of the text to get it look like something that you can see better. And then now that we have that, we'll go ahead and enter our program just up to 146. And you see at the top there, it printed all the characters from 1 to 46. Now I also turned off my cursor, so I'm going to turn it back on here. And then down here, I'm going to enter the rest of it. So we're going to skip. We could do 147. Well, we don't want to erase the screen, so we'll skip 147 since it clears the screen and just go right to 255. Hopefully it doesn't do anything else weird. And then you can see the rest of the character set. So this is the first half, and this is the second half. So basically it's going from 0 to 255, but like I said, once it's at 147, it's always going to clear the screen. That's why I set it in 2 separate sections. So hopefully that makes sense to you. So like I said, we'll cover that more and more as we go along. So we know how XC works now, and it talks about the function keys in here. So the function keys, I'll just bring up a Commodore 64 as an example for this, so you can see it for yourself. These right here in the end, these are the function keys, F1, F2, F3, and so on. F1, F3, F5, F7. Those are your function keys on your Commodore 64 keyboard, and you can just use them to program things. You might see in games if you press them, it brings up an option menu or pauses a game or whatever. This is basically all that example is saying is you could use them and you could program them to do different stuff with your game and stuff like that. And these are the character values. I'll zoom in on this to show you. So if I print these on the screen, you probably won't see, you may or may not see anything. I'll print them anyway. Yeah, it's not going to show you anything, but you can control these to look for the function keys. So for example, if I wanted to write a real quick program to check for the function keys, let's do that real quick here. And you say equal to that value, 137. Yeah, well, let's do it with the first one. So I don't know where they're located on the device, but if you had this on a Commodore 64 keyboard, it would tell you which key it is. And this would be function key 1. And you just go back to the loop to get the next one, so on. Now if I press keys, you probably won't see it unless I figure out which one of these are the function keys. And, oh, that's probably the F1. Yeah, it actually is the F1 key. How cool. So the F1 shows function key 1. So if we change it and we add a new line here, let's just set this to like 100. And 40 we'll set to the next function key, just to kind of give you a taste of what this is about. I think you'll probably figure it out quick enough, but we're going to skip the next one, and then just going to print that function key F3, oops, F3, and so on. I could actually add the other one in here too, doesn't really matter. 137, function key F2. You could just program them all that way. So as we press the keys, F1 is F1, F2 is F2, F3 is F3, and you could just program all the way up to F8 with those CHR string examples. So we just know the get key is going to define if there's no key found here, it's going to go back to line 10 and look and wait for a key. And then once it has a key, which if we print a string down here, you'll see the last one I entered. Oh, actually, I didn't break out of it. Let me see. Oh, it's not going to print it actually, because there's no value to print for it. But basically, if we actually that, I'm getting out of hand here. But anyways, that's what it does, is it defines how to do the function keys. So I don't want to make this video go over, so I just wanted to show that example. Let me save that. So also, before I forget, here's an example of the book here. So I just went ahead and typed this in. So it's very similar to the first one. So you have to press F1 for it to do something. It tells you press F1. And this basically is a similar, it prints a message on the screen, looks for the keyboard. If there's no key found, it stays on this line to wait for a key. And once it gets a key, this is basically saying if you haven't pressed the F1 key, remember here earlier, 133 is for the F1. If you haven't pressed the F1 key yet, then we're basically going to go back to 20. So we're going to reread the keyboard again and wait until somebody presses 133 and it says you pressed F1. Now you could also change it to 2, and then it just changes this message to F2. If you wanted it to say press F2, you have to go ahead and change this message to, of course. And now it'll just be looking for F2. And as soon as you press the F key at the top of your keyboard, oh, for some reason I just locked up. Let me see what I did wrong here. Oh, it's 137, not 132. 132 wasn't even in the function keys. So let's do it again. So if I press F2, it says you pressed F2 and it ends. Okay, so we're going to continue on our next example. Now we're going to learn how to convert strings and numbers. I talked about this in one of my earlier tutorials. But there's a way to take the character string and convert it into a number. And that's usually something called the val statement, also known as the val-line statement. So you can see an example here. I'll run this and show it to you real quickly. The value of 64 is 64. So what this is saying is the value of character value of 64, we've now converted it into a number. So it's saying the value of the character string of 64 is A equals val A string, which is 64. And what does that mean? Now, if I hit A, for example, you see it's a 64. If I hit A strings, you'll see it's a 64. However, you can't sit there and do something like this. You can't say A strings times 2. It'll give you an error it doesn't understand. It says, I don't understand, because you can't multiply a string by a value. But since we converted it like that, we can now safely multiply it by a value, and it's 128. So if you have some character data that's stored in strings, some numbers, you can convert them to numbers so you can use them for calculations. So as another example on this, and let me just clear the screen on this so we can clear it every time. And it says the value is 64. If we say 32, for example, it'll do the same thing and just say 32 this time. The value of 32 is 32. And if we take A times 32 or A times, 2 or whatever, it's basically just saying 32 times 2 is 64. So it's taking that value of 32 and it's storing it into this letter of A. So now A is equal to 32, and then it's just printing that value on the screen. And then, of course, we can use it for calculations. So sorry if I was rushing through that, but I try to keep these 45 minutes in length, and we're getting very close. We're at 38, almost 39 minutes right now. So I want to go into random and basically show you what random is, and we'll try to get a program if we don't run out of time here. So random is this way of taking a random value and enter it into your computer and basically printing it on the screen. So if you see that number, 0.132797837, that's a random number, but it's just basically rounding a number between 0. Between 0.0, excuse me, so anywhere between 0.0 up to 0 is what this is doing. Notice it's not 0, it's a number less than 0, basically. So, or a number at 0, I'm sorry, I probably said that wrong, but anyways, what random does is it allows you to pick range of numbers. You can see here the values range between 0.00 to whatever, 0999. That's an example, and we showed the print 0 there, and it's basically calculating as a decimal value, and that's what it just did there. And we're going to basically show you how to convert that into a regular number. That's the next example here. So let me move this over and just print that next example. And if you add a 1, it'll basically start it at 1 every time. So watch this. As I hit through this number each time and I go back over it, you'll notice the number is changing each time. Not always given a value. There, got a 3. It's got a 3 again. 2. If I wait a little bit, now it's got a 5. Wait a little bit. 4. Basically because it's running off a timer clock inside the computer. That's how random values work. Now it got 6 finally. So it picked up the 6. It went and it ranged it from 0 to 6. So if you want to make a higher number, you just increase that second number and then put the +1. You don't have to have the +1, but if you don't use the +1, it'll go back to 0 eventually. Now we have to erase these or you might not see the true values. Actually, I think you will. Let me see. This is a way of printing random numbers on the screen. Now, why are random numbers important? Because you can use random numbers for like examples. I'm going to try to come up with an example, maybe 2 here. Give me 1 second. So I've listed an example on the screen, and I'll go ahead and run it and explain it. Now you see all these crazy numbers showing up on the screen. These are random numbers. So the computer's going through the clock, and it's figuring out different numbers that it can pull out each time. If you look at our example here, you'll see what it's doing. Basically, it's clearing the screen. And this is an example we learned earlier about setting a random number, RM for random number. The integer value converts it from a decimal into an integer, so you don't have the dot after it that you saw earlier. And this is picking the value between 0 and 50. And then this is basically printing that value to the screen, and this is going to 10, basically so we can keep changing that value. So once again, if you change the second number here, it's going to print higher numbers, lower numbers, or whatever. We could just set it to +1 to skip to 0, and you'll see a lot higher numbers this time. So now it's time to come up with an example. Okay, I've got the next example here. I'm going to go ahead and run this just to show this to you. So I've added some extra things here. They'll show you how to create a title screen. So here's a title screen, which is using GOSUB. And then if you press any keys, it doesn't do anything, but as soon as you press the space bar, it begins. And it's a simple program just to print a random dice roll. Every time you run it, it'll do the same thing, space bar. It'll give you a different number. It usually should give you a different number between 1 and 6, which is common on the regular die. I should actually make that random die, not dice. So we'll call it die roll. Okay, so it makes sense. And I'll just go over the program here. A lot of the stuff should be pretty familiar already, but line 1 right here, for example, this is just dimensioning our multi-dimension array for our CH, just for character. We're going to do 4 rows by 3 columns. And then we're going to set some variables here. BL equals 6. And actually, I probably don't need this one over here. I used this one earlier. I'm going to erase this one. We don't need this one anymore. Heck, we might not even need the VL. Oh, the VL. Okay, so the VL is the value. That's the random die that's being generated here. So it's picking from 1 to 6. This is just positioning of a tab, basically, so a variable we can use later in the tab placement. Now, we learned about GOSUB earlier, so you remember when you GOSUB to a line, you're going to always end up back under that line. Notice there's 2 GOSUBs here, though. So once it does 1, it's going to return from that value, and then it's going to look at the second one, go to that number, and return from that value. So let's follow that along. So it's going to 360. So we'll just print out 360 here with a dash to kind of see it. So basically what it's doing when it first runs the game is it's going to clear the screen, and it's going to set a poke 214, 7. Now, you didn't learn about this yet, but this is used in the character. Well, basically what I showed you earlier, it's the map in the Commodore 64-8. And what it does is it controls the vertical position of the cursor on the screen. So this moves the cursor down 7. And you always want to use a print statement after that so that these work. If you don't use a print, it doesn't work right for some reason. And then you're going to use 211. I think it's to reposition the cursor. And then you're going to use 211, 10, which controls how far over the cursor is from this position over to here. So basically, they count. If you like put the cursor here and you count 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's kind of where the first position is going to begin, where you saw the name of the game, where it says random dice generator. I need to make that die again down here. And then after you clear the screen and you position it, Then you're going to change 646,6. I showed you that earlier, but that's going to change the cursor color to whatever the color that is. I don't know if that's green or blue or whatever. I think that was blue. And then print random die generator toward the center of the screen. And then after it does that, it's going to do another position here. And it's going to say position vertical 10 lines down from the top. And it's going to horizontal position. Horizontal means left to right from 0 to 8. So if you count over 8 here, that's where this message is going to start. And this is just basically our special characters or whatever, changing the color of the message here for press. And then this turns on the reverse mode. Remember how it puts the inverse mode on, and it turns it off here at the start. So that's why you saw it in like a little inverse mode when it started. And this is just reading the keyboard here. So we're going to read keyboard. If there's no keyboard entry, we're going to go back to pointer to keep rereading the keyboard. But if you see it says K strings equals CHR strings 32, now usually you see me do something like K strings equals Q or equals A or whatever. The CHR strings we learned about earlier is a character set. So the character set for 32 is the spacebar. So when it says K equals K strings equals CHR strings 32, then it's saying look for the spacebar. If you get it, then we're going to return. And remember our GOSUB earlier, this is basically going to return and start off to the next GOSUB. So go-to pointer is going to keep repeating the loop if we haven't pressed a key yet. So this allows us to wait for the key, the spacebar, before we return. And I'll run it one more time to show it to you. So see how it's waiting, and then here's the inverse mode for the spacebar I showed you. And it's waiting, nothing. And as soon as you press spacebar, it clears the screen, and it runs the next part of the program. So the next one we're going to do is we're going to GOSUB to 310. So let's just list 310 this time. Right there is good. And basically, as we saw, first it went through this one, and it printed the top message, and it checked for the keyboard. This one is going to say, after we press the spacebar, clear the screen. And then now we're going to use our famous poke 53280,3, which changes the border color. And this is going to change the screen color to black. And this is just changing the cursor color to yellow. And then return. So it's not going to do anything else. It's just setting up simple coloring for the game to get it all set up. That's what I mean by initialization. You can set those up in GOSUB, so it works so easily instead of having to go to and all this stuff, and it saves a lot of trouble. So after we've done our GOSUBs, we're going to basically set a variable or a value, random value, a DC from 1 to 6. Now remember our BL earlier is 6 here, so it's basically picking between 0 to 6. That's just a way of making it check. If you wanted to make it a higher number, you can go ahead and insert it and change it there. I just set it for a variable in case you wanted to change it later. It's always a good idea to use variables in programs like that so you can change them later. And this is just moving the cursor down the screen, so I probably won't even need this. But anyway, next thing we're going to do is we're going to read in our multi-dimension array. So this program is taking an example and advantage of a lot of things we've already done. It's going to read a multi-dimension array from 0 to 3 here. And then it's going to also read column from 1 to 3. And if you look for the data statements down here somewhere, so we can find them here. Probably down here a little farther. They're down here at the bottom here. You'll see these are the areas it's reading in. Now you probably don't know what these are yet. I'll run the program one more time. Now keep in mind you see 111, 163, 163, 112. I'll run it again. And I'll press the space bar. Press space bar. And you'll see right after the random die roll, it shows this little character here. Now, if you look and you print CHR strings 163, you'll see what it printed a line. So basically, this is just a way of accessing those internal characters inside of your computer's memory. Let's do it again. So it basically reads them in first, and then it's going to print a message, the random die roll is, and it's waiting for a result. And then it's going to basically reread our loop again. So it already goes 0 to 3, because remember, it stored them in the array earlier. So now that they're stored there, we can, check them. And then once we've gone through the first part of the row, we're going to print tab. So we're basically going to move it over 12. I think it was 12. What's TB equal to 12? Or 10 or something? It's equal to 14, excuse me. So it sets the 12 to the position 14. You could just put 14 if you want in here. It's no different. I use this in case I need to reposition stuff, but you can still do 14. It'll do the same thing. And then we're going to use our character set, CHRW, CO. So remember, this is necessary so that we can get the background character. Otherwise, this is going to print a number on the screen. Because if you learned earlier, remember when we were doing the axis stuff and all that, we were basically showing the value hidden behind that character set. So, whoops. So if we print that value to the screen, then you'll see the Q appear. That's basically all that's doing right there, is it's converting it from a number into a character so that we can see it on the screen instead of just seeing the number. If I take that out, you'll see it print only numbers, and I can show that to you real quick, even though I'm going over here a little bit. See, it prints the numbers instead of the actual characters. So let's put it back the way it was. I'm going to access that array inside of the character set. Make sure it works. Okay, so it's back the way it was. And, whoops. This one's going to go over a little bit, sorry guys. Okay, and then once we've read that, we're going to print the character set. This next one, it says if CHRW got RW, so if the multidimensional array is checking the row and the column and there's a 112 in there, or if it also finds a 167 in there, then it's going to set this VE equals VE plus 1. And I can actually get rid of this VE. We don't need this. I was using this earlier for a different example. So I'm going to take out the VE part. That was when I was using the 214 and 211 memory locations. But it'll do the same thing. I'll show it to you. So we're going to do the same thing there. And let's print it back. So remember the 112 and 167. If you look down here, what it's doing is it's scanning through our data statements. As soon as it finds a 112 or 167, it sets a print statement so it can print on the next line. Otherwise, it's going to print a long line all the way across the screen. That's how I got it to position the box on the screen properly. And then 1215 can go away. That was just an example I was using earlier. Oops, too far. And we just finish up our next statement, and then once we're done with that, we're going to position the cursor. Remember the 214,11 earlier? It's going to position it down from 1 to 11 down the screen, and from 1 to 15 to get it in the center, and then it's going to print. It's going to change the color of the background character to DC. So basically, it's changing whatever the random color is changing each time. It's going to put it in memory location 646, so it can keep cycling through different colors to show a different number inside the cube, and I'll run that to show you what I mean. So you see this number inside the cube? This is that poke 646. That's changing that every time. So if we do a poke 646, comma 3, and then print whatever, DC after it, you'll see it changing every time. And essentially all it's doing is just changing what that cursor's in the middle. So it always has a different color, reflecting whatever the DC value is. And you see DC is 6 here, and peak 646 is 4. So it's just keeping track of the coloring to change it on. Get rid of the purple there. Okay, so hopefully that makes sense. And then it just basically positions it, changes the color, and it prints DC, which remember DC is just that that value that we're putting on the screen every time. So it's printing that random value. DC is always going to change by that random variable earlier. So I didn't mean to go over so far. I hope I didn't go too fast on this. If you have any questions about it, just go ahead and put them in the comments. I always try to get a demo example out there every time. This one took a little bit longer than I expected. You won't be able to tell because my clock's been off the entire time. But anyway, usually you can tell. Or you can watch the video and figure it out maybe. But anyways, I hope you guys enjoyed this example. And yeah, please like, favorite, subscribe to this channel. Always look forward to hearing your feedback, and we'll continue doing the very basic tutorials. And yeah, I'm enjoying this so much, and I'm all hyped up, and I'm looking for some more examples out there and some more slideshows. Well, of course, we'll try to finish the other ones. And you guys have a great night, and take care.